And welcome to another A-Level Maths Made Easy video. This time we're doing the Year 12 integration. Again, a topic that can be kind of tricky. The actual integrating normally isn't too bad, but the applied questions can be a little bit tricky. So you're probably wondering, what is integration if you haven't seen it before? Essentially, in maths, every operation, so timesing, dividing, etc., has an inverse operation. So with timesing, the inverse is dividing. With adding, the inverse is subtracting. With squaring, there's square rooting, and so on. That is a fundamental principle of maths. Essentially, the idea is, if I do something to a number, I should be able to undo it and get back to my original value. So for example, if I do 2 times 3, I get 6. I should be able to do something to 6 to get back to the number 2, as an example. Integration is the inverse of differentiation, so its job is to undo differentiation. Now, if we remember when we differentiate, so if I was going to differentiate, let's say, x cubed, when we do dy by dx, what we do is we bring power to the front, power to front, which when I say that, it does mean multiply essentially, and then we subtract 1 from the power. Subtract 1 from power. And when we do this, actually I put a little subtract sign just to make it super clear. When we do this, if we're doing integration, we want to be able to do the exact inverse. Now, inverse doesn't mean the opposite. So we can work out how to integrate something without actually knowing how to integrate something by just doing these steps backwards and doing the opposite. So the common mistake I see when students do this is they do it the opposite. They'll bring power to the front, or they'll leave it there, or whatever, or they divide by the power. So instead of multiplying by the power, they divide by the power, then they subtract 1. But that's not the same. That's doing the opposite, not the inverse. When you invert something, you also work backwards. So you're starting from step 2 and doing the opposite. So you're not dividing by the power and then adding 1. Instead, you're adding 1 to the power. So that would be x to the power of 3 plus 1, so 4. And then, what's the opposite of multiplying by the new power? You divide by the new power. And that's it. You can test this out, so I'd recommend if you differentiate x cubed, and then you want to integrate it, you should get back to x cubed. So when you differentiate, you get 3x squared. Integrate, you get 3x to the power of 3 divided by 3, x cubed. So, there is one thing though. There's one problem. Do you remember what happens if we have like a number plus 4 over here? Right? Well, when we differentiate it, it goes away, doesn't it? It becomes 3x squared and then it goes away. So when I integrate, I need to have the ability to bring back the constant. The problem is there's no way to work out what that constant is straight away. So instead, what we do is we introduce a letter. Remember, when we don't know what a number is in maths, we just use a letter to represent it. So plus c. That is called my constant of integration. Because it's there just in case there was a constant when we in the original function that we differentiated. Now bear in mind, this c can be any natural number. It could be, sorry, not natural number, any real number. It could be 0. So for example, in the case of just x cubed, it would be 0. But if it's x cubed plus 4, then we'd have a plus c, which we'd then have to work out or use some other piece of information to work out what that value is. But the key point here is when you differentiate something, you do lose information. You lose what the constant was if there was one. Because I have no way of knowing if there was one, I have to introduce a plus c. That's just the law. That's the rules, okay? But that's all you really have to do. So if you want me to give you a general form, just like I did before, that's not how it looked, x to the n dx, then all we do is we're going to write x to the n plus 1, we're going to put a at the front and then divide by whatever the new n plus 1 is. And then we are going to have a plus c every time you integrate, bar none. So let's get to it with some other questions. So jumping into something with indices, just because I want to make it a bit trickier, because again, the topic isn't too bad. Normally you'll get a question where it says integrate this, giving each term in its simplest form. So the first thing I would do is, well, I'll do what I said, right? So first thing we do is add 1 to the power, so that's 4x to the minus 1. And then we divide by the new power, which is minus 1. Do the same thing here, we get plus 3x to the power of a half. I do notice a few year 12s, by the way, making mistakes when you're adding or subtracting 1 from fractions, which can be a bit... It's an easy way to make a mistake, right? Over half, and then of course we have the plus c. Simplifying, we have 4 over minus 1, so it's minus 4. Then we have 3 divided by half. Again, use a calculator if you're unsure, right? 3 divided by half, which does give you 6x to the half plus c. Now, that will be it. So you get a mark for the actual integration and a mark for the simplification. That's what you have to do. So coming on to a slightly trickier question, in my opinion, we have this question. So p and q integrated gives you 2 over x plus 10x plus c. Find the value of p and q. A really common style of question, not just in integration, but in pretty much all topics in A-level maths, is the idea that they tell you to do an operation, they tell you it equals something else, and you need to work out the missing variables, basically. Not variables, in this case just algebra. So we have p over 2x squared. The first thing you do is you'd put this into a form you can integrate. So it'd be p over 2 x to the minus 2 plus pq and then dx. And all you'd get is, so again, add 1 to the power gives me, in fact, I could write it like this, to the minus 1 over, since it's already over 2, I'm also going to have a minus 1 there, so that does just make minus 2, which is something vaguely interesting, I like to think. Plus pqx, and then of course plus c. So again, the plus c and the plus c are already the same. And they're telling me that this equals 2 over x plus 10x plus c. So in other words, I know that p, and again, if you want me to write this in another way you could put it is you could put the x on the bottom here because it's x to the minus 1. But I know that the pq is equal to 10. How do I know this? Well, again, this is a really common, again, I've said this in the previous videos as well, a really common strategy is called comparing coefficients, where you look at the coefficient of the x term, and since we know that these two things are equal, we know that they should simplify to each other. So pq should give me 10. And everything in front of, in this case, the x, so the 2, should be equal to p over minus 2. Just like that. So now, of course, we can solve. So we get p is equal to minus 4. Subbing that into here, we get minus 4q equals 10. So q is equal to minus 5 over 2. Whoops. That one and that one. For 5 marks, I think that is remarkably generous. But again, it's the comparing coefficients and it's doing the integration properly that really matters. So integration can be really, really useful when we are given the first derivative of an equation or a curve, and we need to find it again. So again, remember when we differentiate something, we'll get the f prime. You can also call this dy by dx if you'd like. It means the same thing. And what we're going to do is now work backwards to get the actual equation of the curve instead. And you may notice they've also given me an additional piece of information. I wonder if you can kind of guesstimate where that is going to come in handy. So the first thing we need to do, in order to kind of undo the differentiation, we need to integrate. But this thing here is pretty hard to integrate. So what we're going to do is we're first going to simplify it. So I'm going to write x squared minus 2 over x to the half. And then all we're going to do is simplify that one more time because we don't know how to integrate fractions yet. X to the half divided by x squared divided by x to the half will be x to the power of 3 over 2, because 2 minus a half, and then there'll be minus 2 x to the minus a half dx. Now integrating this, we get, so add 1 to the power and then bring it and then divide by it. So I'm going to show you that it's going to be 2/5 x to the power of 5 over 2, and the reason for that is we get x to the power of 5 over 2 divided by 5 over 2. And remember, when you divide by a fraction, you need to keep flip change. So times by 2/5 because we flipped the second fraction. So just keep that in mind. Then here we're going to add 1. We get to the power of a half. Divide by the new power, so 2 divided by a half will give me 4. So minus 4 x to the half, and then remember r plus c. Now you can probably see where this is heading, right? it passes through here. We need to find the equation for c. This is not an equation for c yet because we have an unknown, which is plus c. But they've given me a coordinate. Now you're probably seeing what we need to do. So when x equals 4, the function should equal 5. So we get 5 equals 2/5 4 to the power of 5 over 2 minus 4 to the power of, times 4 to the power of a half. Am I doing that right? Yeah, cool. Had a little brain fart there. Then I'll use my calculator just to work out all that stuff because I'm lazy. And we have 2/5 times 4 to the power of 5 over 2, so 2.5, let's just call it. Minus 4 to the power of 0.5. Again, that's a half. Gives me 24 over 5. So 5 equals 24 over 5 plus c. So then minusing 24 over 5 from both sides, we get our value for c, and we can sub it in, and we're all done. So it should be, it's going to be 1/5, I'm pretty sure. 5 minus answer. Look at that. Too easy. Yeah, let's leave it as a fraction actually, because the rest of my things in it as a fraction. So then we have f of x is equal to, it was 2/5 x to the power of 5 over 2 minus 4x to the power of a half plus 1/2 as our final answer. And again, these questions can be 4 or 5 marks. Really, really nice questions if you know what you're doing. And that is again why they give you that piece of information. Remember, they never give you information you do not need. This is the last bit of simple content we need to do before we go on to 2 questions that are actually pretty tricky. So far we've been doing something called an indefinite integral. And the reason it's called an indefinite integral is because it doesn't give us a numerical answer. However, we can do this, which is a definite integral. And it is definitely more interesting. Not really. So you might have noticed that there's these 2 values, right? 1 and 9. What does that mean? Well, what it means is we're going to evaluate our integral between the values of 1 and 9. I'm going to show you exactly what that means in the next question and exactly what this actually calculates in the next question as well. But it is, in my opinion, pretty interesting. So, what does this mean? Well, to be honest, it kind of means the exact same thing. So your first step actually stays exactly the same. We're going to write it out in a form that we can actually integrate. And then we're going to do the integration just like normal. I know, very interesting so far. I'm going to put square brackets. You'll see why in a second. But we get 2x to the power of 2 divided by 2 gives me x squared. Here we're going to have minus 3x to the power of 3 over 2. So we're going to have over 3 over 2, which is going to give me 2. So minus 2x to the power of 3 over 2. And then, of course, we're going to have our plus c. And we still haven't used our limits yet, 9 and 1. Well, all we do is we substitute both of those values in, and we subtract them from each other. So we start with the top limit. So we're going to do 9 squared minus 9 to the power of 3 over 2 plus c. And then we're going to subtract 1 squared minus 1 to the power of 3 over 2 plus c. Now you might notice that the plus c's cancel. And just as a bit of a spoiler warning, they will always cancel. Because when you sub in values, it's never going to affect a constant. So that constant is always going to disappear. So if you want, you don't even need to write it. But I wrote it just to make super clear that that is a thing. Now we're actually going to get a numerical answer. So all we're going to do is we're going to whip out our calculator one more time. And we're going to do 9 squared minus 9 power of 1.5. Ooh, okay, I thought I pressed another button there. Oh, fine, I'll do it this way. There we are. Subtract 1 squared minus 1. $28. We get a number. Crazy. Now, of course, the question is, what on earth does that number represent? So when we differentiate, we get a gradient. What happens when we integrate? And for that, we're going to go on to the next question. And believe me, it's going to make a lot more sense. Here's the question. These can be 6, 7 marks. Really nice questions. But we need to first start by sketching the curve. And honestly, this is pretty quick. So if you go back to the kind of sketching graph videos, that might make a bit more sense. But as you can see, we're going to have 3 x-intercepts. So that's going to be x equals 0, +1, and -3. So let's label those. We have -3 over here. We obviously have 0 right through the middle here. And then +1 over here. And because it's a positive cubic, it's going to come up, down, and then up again. Oh, beautiful. Beautiful. Now, hopefully you didn't read the rest of the question while I was doing that. When you integrate, it gives you the area between the curve and the x-axis. Now, there is a common way of saying this that is wrong. Some people say that it is the area under the graph. No. So for example, in this case, from -3 to 0, that is the area under the graph. But it's also this area, and that area is not underneath it, it's above it. So this is the technical way of saying it. It's the area of the region bound by the curve and the x-axis. I prefer to say the area between the curve and the x-axis because I'm not pretentious. Not always anyway. And that's it. That's what integration gives you. So if I integrate this curve between -3 and 0, it will give me the area, this first red area here. Interesting, right? It's pretty cool. It's pretty cool. And if I integrate it between 0 and 1, I will get the area over here. Now, here's where it gets complicated. A little bit complicated. Areas in the positive x-axis will always be positive. But can you see that this area is actually underneath the x-axis? That means the area is negative. So, if we want, now you might be thinking, how on earth can you have a negative area? And you're 100% right, you can't. Which is why when we integrate between 0 and 1, we'll get, let's say, -4, but we're going to say the area is 4, not -4. The problem with this question is I cannot integrate between -3 and 1 because this area is positive and this area is negative, which means they will cancel each other out. If you have a perfectly symmetric graph, they actually cancel out perfectly and you get 0, which is obviously really wrong. So, what we need to do is we need to do 2 separate integrals. Between -3 and 0, we'll get a positive number, let's say 28. Then between 0 and 1, we'll get a negative number, let's say 12. But we make it positive and then add the 2 values together, okay? This leads me to tell you what integration actually is. If I asked you, personally, to calculate the area under the graph before you did A-level maths, what you would probably do is break it up into lots of little thin strips and then find out the area of each of those strips and then add them together. Okay? Valid. Integration makes those strips infinitely thin. So it makes it perfectly fit to this graph here. So it's the perfect way of doing it. The way differentiation and integration were kind of invented, so to speak, is very interesting in my opinion. So again, you know where we had the tangents before with differentiation? But what if you made the tangents infinitely small, which means that they perfectly conform to the curve of a graph? It's the same thing with the areas. The common way of working out the area of the under the graph is by splitting it up into shapes that you can actually work out the area of. Normally trapeziums. Okay? So for example, if you had like a curve like this, you'd split it up into a bunch of trapeziums which kind of fit the graph. But as you can see, there's overlap here, right? There's empty spaces. But then they said, well, what if you made those trapeziums really, really, really thin? Well, the thinner they are, the more accurate your value. So if we made them infinitely thin, well, that means we'll be infinitely accurate. That's the idea behind it. And that's where they kind of colloquialized these kind of rules that we've used here. So that's the idea behind this question. We're literally just going to be integrating between -3 and 0 and 0 and 1, and then making them both positive and adding them together. We cannot do -3 and 1 because the negative area will cancel out a bit of the positive. So again, imagine this is like 32 and this is -12. that means it gives me an answer of 20 instead of what I actually want, which is 44, sorry. So bear that in mind. So let's get to it. We can't integrate brackets yet, so we need to expand the brackets. So what we're going to do is we're going to have y is equal to x. Expanding that, we get x squared minus x plus 3x, that would be plus 2x, and then minus 3. And expanding that one more time, x cubed to x squared minus 3x. And we're going to integrate this twice, once between minus 3 and 0. I'm going to do the exact same thing again between 0 and 1. Yeah, 0 and 1, good. Ooh, spoilers. Anyways, 0 and 1. And it's going to be the exact same thing again. There is good news here. You don't have to do the same thing again, because once you've integrated it once, you can just kind of move it across. That might be a good way to do it. So here we're going to have a quarter x to the 4 plus 2 over 3 x cubed minus 3 over 2 x squared. Because again, remember, I've added 1 to the power and I've divided by the new power. That's all I've done. Then, of course, you have the plus c. First things first, you may notice if you sub in the value of 0, we're going to get 0 in this whole thing, right? We're going to get 0 plus c. So I'm not even going to bother subbing in the 0. But in the other one, I'm going to do a quarter minus 3, it's about 4, it's 2/3, minus 3 cubed, minus 3 over 2, minus 3 squared. And then again the plus c, so then the c's will cancel. So we're going to do 0 minus all of that. Can I scroll down with that? Right. You're going to see a bit of the next question. Oh well, that's fine. We're going to have 0 minus, and then we're going to have all of this stuff. Minus 3 still. Squared this time. And yeah, that's it. 45 over 4. So again, as I said, it would be positive. Now again, we've already done the integration, so we're literally just subbing in between 1 and 0. Now again, the good news here is we don't need to do the 0, because it's 0, right? It's going to give you 0. Thirds 1 cubed minus 3 over 2, 1 squared, plus c, and then obviously minus, it's going to be 0 plus c. So again, c's cancel out, as they always will. So all I'm going to do is I'm going to be kind of clever. I'm going to go through, I'm going to delete the 0 from the front, and I'm just going to change all of these to 1s. It's all about saving time. Minus 7 over 12, as I said, is going to be a negative number. So what we're going to do for the area is we're going to say it equals 45 over 4 plus 7 over 12. Because again, areas can't be negative. Okay, that's just a fault in the calculation, so to speak. That is because mathematically speaking, you can have negative areas. It's just in real life, you can't have negative areas. 71 over 6. Perfect. And if you want to give it units, you'd have to just say unit squared, because I don't know if it's centimeters or meters or whatever. That's it. Now, some of you may have seen on your calculator that there is this handy-dandy integration button. You can use it, but some questions will say solutions based entirely on calculator technology cannot be accepted, so you do need to do the substitutions and things like that. Otherwise, they'll give you nothing. So bear that in mind. Let's move on to the last example, which is where things can get a bit hard, but I'm going to show you it's really not that bad. So here's the kind of questions which will probably appear in the end of Year 12 exams, and obviously they can appear in Year 13 exams as well, where they get slightly trickier. And it's trickier because this area looks whack, right? It looks crazy. The thing is, and the great thing about integration is you don't need to do that. You know those end of GCSE questions, right? Where they would have like a pentagon inside a circle, inside of a rectangle, you had to work out the areas. It doesn't matter. You still just are going to integrate. That's the great thing about it. It's integrate, right? Because integration does the work for you. You do not need to memorize any formulas for area because you can always integrate to get the area. But let's start with part A. And there's a special reason why they've asked you to do this for part A. So find the coordinates of the points where the line and the curve intersect. I mean, that's going to be 0, 0, but whatever. So to do that, we're going to equate the two things. So 10x minus x squared equals 2x. Move everything to one side, so minus... I'm going to minus 2x on both sides, so we get 8x minus x squared equals 0. Factorize to solve. We're going to have x, and we're going to have 8 minus x equals 0. So either x equals 0, well, it's not either, it's and, x equals 8. And that does make sense, because obviously this is our 0, and that's our 8 value. Makes sense. Now, calculate the area of the shaded region. A lot of people here will get a bit worried, scared, plenty of other adjectives I can use to describe them. But remember what integration gives you. It gives you the area between the curve and the x-axis. So if I integrate the curve at the beginning, not the straight line, so this one, it will give me this. It will give me the area of this entire region, including the white part at the bottom. If I integrate the line, it will give me the area of this triangular shape. Could you use the area of a triangle formula? Absolutely. The problem there is you would have to sub in x equals 8 to find out what the height of the triangle is. But you could do it. I'm not going to say you can't, because that would be a lie. You could absolutely do it. So again, you could use the area of a triangle, but why would you, right? Actually, you know what? I should actually remove a bit of this, because technically speaking, it would only go up to here. Right, that's why I said it's a triangular shape, by the way. Okay? So if I just literally integrate the red part between 0 and 8, and then subtract the integral of 2x between 0 and 8, I'm done. And it doesn't matter how complicated the area is. It's the same thing. So if they gave you like two curves intersecting each other, and you had to work out the area, that looks complicated, right? But it's not. You're just integrating one curve between 3 and 4, and the other curve between 3 and 4, and subtracting it. That's it. That's why these questions, 8 marks is a huge amount of marks, but it can be worked up to 9 or 10 marks. You're always just going to do integration. And it's so good. It's really, really worth the investment. So let's start, shall we? We're going to have the integral between 0 and 8 of 10x minus x squared. I will say, by the way, that because this question doesn't say, you can't use a calculator, you could just use a calculator for the whole thing. But in the spirit of things, I've noticed more and more recently that they have that disclaimer, you can't use a calculator, so let's do it properly. But that's my answer. Well, as soon as I work it out anyway. So again, let's do this. That would be 10x to the power of 2 divided by 2, so that's 5x squared. Then you're going to have x to the power of 3 divided by 3, so minus... I like to put it as a third x cubed, but it really doesn't make a difference. I'm not going to write the plus c. I'm hoping you're okay with that now. Then again, that's 2x squared divided by 2, so it's just x squared. Between 0 and 8. And again, remember, with zeros, the answer is always going to be 0. So I actually only need to sub in the 8 for both of these. Right? So 5, 8 squared minus a third, 8 cubed. And again, I'm technically minusing 0, because if I sub in that, so I'm not even going to do it. And minus the green one, 8 squared. Oops. And again, remember, since none of my values are, none of the curves are underneath the x-axis, I don't need to make it positive. I can literally put this in my calculator now, get the marks. 6 marks for 3 lines of working out. That's crazy. Crazy. So when people say these questions are difficult, it's honestly, practice this more than anything, because it's so nice. It really is. Anyways, enough of that. Again, I'd recommend just remembering that 0 always will equal 0, so you don't usually have to write it unless the 0 is on top, because then you're going to have 0 minus something. Whereas in this one, it's going to be the answer minus 0, so I'm not even going to bother putting it. Get rid of that part of the calculator, and yeah, just sub this in. So 5, 8 squared minus a third 8 cubed, take away it squared. 256 over 3. 6 marks. 8 in total. Right? Integration, I'm not going to lie, year 13 is really hard. It's obnoxiously hard, I'd say. But this is all you really need for year 12. If you can do this, this is the hardest style of integration question you can get. Remember the principles. They have to give you enough information to do it. And with the areas, just remember the core things. If it's beneath the x-axis, it's going to be negative, so you need to make it positive yourself. You have to manually do that. It's one of those few times in maths where you have to do it manually. And yeah, just really when you're practicing this, take it slow. A lot of A-level students, they overcomplicate things, which is not good. Keep it simple. That's the best piece of advice I can give you. And the second thing is take it slow. They've given me 6 minutes to do this. Even when I was explaining it to you, it didn't take me 6 minutes, right? So take your time. As if you're explaining it to someone else. Do it in your head. Say, oh, okay, so this is what you would do. You would do between 0 and 8 because that's where the intersection points are. You would do the curve minus the straight line because the curve is on top of the straight line. So we have that. That's what you need to do, right? That's what you need to do in your head is talk through it. But I hope to see you in the next one where we go on to some of the stats and mechanics stuff.